Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 14, Liquids and Solids Part 1. We're in Chapter 10 of your textbook. Of all of the open-ended questions over the course of the last 5 or 6 years, the most of the questions, like the greatest percentage of them of any topic, are on the topics in Chapter 10. Here are our objectives for today's video. Pause here. So you've probably heard me talk about the term intermolecular forces before. We're just going to go into them in a lot more detail here than we ever have before. So these are the forces that are between different molecules. So not within a molecule, that's an intramolecular force, but these are the forces between two or more different molecules. Intermoleculars hold molecules together. When I say together, I mean as a part of something cohesive, like a liquid or solid. I'm not saying that it's causing it's the bond forces. So in order to separate molecules, meaning if we're going, say, from solid to liquid or liquid to gas, you must add energy, and that's why both of those processes are endothermic. Pause here. You do not need to draw the picture. All right, so now what we're going to be doing with this video is discussing the different types of intermolecular forces that there are. The types are not limited to the ones that are in the video. We're just going to talk about the most important ones. So the first is a dipole-dipole interaction. So di meaning two and pole meaning a part of a molecule that has a charge. So when a molecule is polar, you've got an end that's partially positive and partially negative. That little symbol there, I think it looks like a lamed, but it's actually the Greek letter lowercase delta. The molecules can line up in such a way that there's going to be an attraction between two molecules, and that's what the picture is showing there. So this will be anything that is polar covalent, meaning that you have a difference in electronegativity. Pause here. You do not need to draw the picture, but you should look at it. Right. Hydrogen bonding is a subset of dipole-dipole interactions, but these can only occur when you've got hydrogen that is bonded to oxygen, nitrogen, or fluorine. Oxygen, nitrogen, and fluorine are the three most electronegative elements on the periodic table. When hydrogen bonds to oxygen, fluorine, or nitrogen, it actually partially ionizes, meaning that the bond is so polar that it gets a little bit closer to the spectrum to ionic bonding than to covalent bonding for that moment. And this is just an especially strong intermolecular force. This is why water has such a high boiling point compared to other H2 and then things in that group, compared to, say, H2S even. Pause here. You don't need to draw the picture. And then the third, but certainly not less important, and this one's probably the most important of the three, are London dispersion forces. So molecules of any sort, whether that they are polar or nonpolar, they can form temporary dipoles, which could attract one another. These temporary dipoles occur because of random motion, well, not exactly random, but because of motion of electrons. And for a fraction of a second, you may have a partial positive charge on one end and a partial negative on the other end. And then it will switch around. But those temporary charges do create real and very measurable forces. Things that are more likely to form temporary dipoles are considered to be polarizable. If or whenever you are discussing relative strengths of London dispersion forces, you should use the word polarizable. We'll talk more about that in class. Pause here. All right, I'm just going to walk through each one. So CCl4, that is a nonpolar molecule because all of the CCl bonds are symmetrically arranged. If that you didn't know that off the top of your head, then you may want to draw that out. So its only type of intermolecular force is London dispersion. Right, CCl3H is a little bit different because those CCl bonds are no longer symmetrically placed around it. It is polar. So in addition to its London dispersion forces, anything that has electrons pretty much has London dispersion. It also has dipole-dipole forces. And then H2O, we have oxygen directly bonded to hydrogen. And that is pretty much what creates a hydrogen bond. Also, it has electrons, so London dispersion is also there. That being said, the hydrogen bonding is far more important in the case of water than the London dispersion forces are. Pause here. So this is actually straight up from an AP exam. I'm going to walk through this one with you. All right, so the question gives the boiling point. A higher boiling point needs higher intermolecular forces. And then it's asking for you to explain why. So Br2 has only London dispersion forces, while BrCl has both London dispersion and dipole-dipole forces. Br2 still has a higher boiling point. So Br2 has the higher boiling point because it has more electrons than BrCl and therefore is more polarizable. So its London dispersion forces are higher than the overall intermolecular forces of BrCl. So I know that I wrote that out in a lot of words, and it's really the important thing is that you included the polarizable. That's something you really, really want to include. And the other important thing is that I talked about the types of forces that are present in both. All right, here are our practice problems for today's video. Thank you so much for watching and have a good night.